Okay. Now, as I said, and I think it's a symptom of what happens when you're given a graphic calculator, never have to do anything by hand. Don't learn it that way, you don't retain it that way. Okay? We write these things out and write out everything I wrote out. There isn't that much. Okay? But notice nobody wrote this out. Okay? So when I say write it all out, it only takes a minute or two. And that focuses you on the essence of the situation. Okay? So if we want to do that problem now, we've got okay, well, from before, get intercepts 8, 0 and 0, 4. Where's there's 6, 4, yeah, 0, 4. Right? So we've got this line. Okay. Now, if you do everything I asked you to do, I'll put this up here. And I understand. You're focused on, okay, where do I put those arrows? How do I get this? And you end up skipping, and you end up then doing your homework the same way. And it's not in the way that's best retained. Now, you might have another strategy for retaining what you learn. Okay. And it might be better than the one I'm recommending, but start with the one I'm recommending and then adapt it. But think about how you're doing the work and how you're going to retain it. Okay. So you have these two, or you have this, and I'm going to draw the triangle up here. Because you don't have to draw this triangle with the legs of the triangle along the axis. Now, I've said go from left to right. Okay. So from left to right, here to here, go here. Now, if we follow the thing this way and then this way, we're going from right to left, huh? Go up here and back here. A lot of people wanted to reverse the arrows. Okay. And that's okay. You know, it's right out anything about the directions of the arrows. So here we've got the arrows. Okay. In this case, we get a path to the left point to the right point. Okay. Now, here's the run. Now, I'm going to write a little more. I didn't ask you to write this. The run is the change in the x coordinate, right? So I'm going to write run equals change in x. This little triangle thing is a great capital delta. You can see how it got rounded out, rotated a little bit, and turned into our capital D. Okay. Around these corners and then rotated about 45 degrees, and you got a big old capital D. It's a change in x, which is x goes from 0 to 8. So it's 8 minus 0, which is, I don't know what language it's 8. Okay. So we get 8 if we do x coordinate that we're ending up at minus the x coordinate we start at. That's another reason I want you to think left to right now, so you don't confuse yourself by doing some right to left. What you really understand, as long as you go the same way both times, it works. Okay, but right now, we're going to do the rise is the change in y. Y goes from 0 to 4. Y is 0 here, it's 4 here. So we do, and I wrote it wrong. I did say what I just said. It's 0 minus 4. Here's we got to be careful. Okay, again now, we're going from this point to this point. We're starting at 4 and we're going to 0. So we do what we end up with minus what we start with. 0 minus 4. Want to get used to that. And it's minus 4. So I've written out a little more than I wrote here, and I want you to start writing this out. Okay? Now, the slope is rise over run, which is negative 4 over 8. At least one of you went from here to here, but you hit all the arrows, right? And you still ended up with the correct slope. And that does work, but as I say, try to keep it left to right now. Anyhow, you get negative 1/2, right? So now you have negative 1/2 here. The box around it. You don't have to put slope equals. You just put negative 1/2 with box around it if you follow this convention. And you know that's a slope. But if you want to write slope equals, that's okay. Now I wrote the slope calculation here, kind of underneath the triangle. Could write it all the way down here. This is a convenient place. Here we got it, and that's how we got it. Now, equation 1 there it is. And we confirm from the graph and the calculation of the construction of the slope that y equals negative 1/2 x plus 4. Okay, now I want you to do the same thing. I'm not giving you numbers. I give you symbols x1, y1, and symbols x2, y2. So all I want you to do right now is draw that triangle. Draw your arrows and write down what the rise is and what the run is. Okay. Now, there's a couple of stumbling blocks, all right? There aren't numbers, so you're not sure what to do when there aren't numbers. And neither of these points is on an axis, so you're not necessarily sure what to do. It's not, and you don't have two intercepts, okay? Now, if you drew the thing the way most of you drew it, you didn't draw it or didn't draw it right, okay? So just kind of notice that. There's a reason I drew it out here. There's a reason neither point was on an axis. Because it works no matter where the points are. Because you can draw the proper triangle, okay? Right there's a hypotenuse. Right there's a horizontal. Here's a vertical leg. And we'll always go from left to right. Okay. Now we've got the run. What's the run equal? It's the change in x. So what's the change in x? Well, x starts at x1, ends at x2, right? There could be a comma there, but it's confusing. Starts at x1, ends at x2. X changes from x1 to x2. What's delta x? Well, if the number goes from 3 to 5, how much does it change? Show me the change. 2. Okay. If it goes from 5 to 3, how much does it change? -2. Good. Okay. So if we do 5 minus 3, do we get 2 or -2? We get 2, right? And that's the change from 3 to 5. So to get the change from 3 to 5, we do 5 minus 3. Now to get the change from x1 to x2, we don't know what x1 and x2 are, but we're going to do x2 minus x1. The same as we would do 5 minus 3 to get the change from 3 to 5. From x1 to x2, we subtract x1 from x2. That's common sense, because everybody answered correctly when I said, go from 3 to 5, what's the change? Somebody showed me 2. You go from 5 to 3, what's the change? Somebody showed me -2. You understand that with numbers, okay? It's the same with symbols. Whatever you end up with, you subtract what you started with from there. Where you end up minus where you started. You really need to know that, okay? So delta x is x2 minus x1. Now we don't have time where I'd ask you to write this out for me, but the rise is your delta y. Well, we're starting here and ending here, right? We start at y1 and end at y2. Your rise is then y2 minus y1. So now the slope equals rise over run equals, oh, heck. It's probably operator error. Kind of stuff on it. Let it do that. Equals, rise is y2 minus y1. Run is x2 minus x1. And that's all slopped up. The arrow and stuff, but it's maybe halfway later. Okay. So there's the formula I tell you not to use unless you have a picture and a triangle and labels of the rise and the run and understand that this is rise divided by run. Okay? You really want to pull all that together. Make sure you totally understand every bit of it. As you do this stuff. So you can do homework pretty mindlessly and pretty quickly just by using the formula without understanding what it means. Okay? So please do it consciously with the pictures. Okay? Doesn't take long to draw the picture, especially if you've drawn it 2 or 3 times already. You got to draw 10 pictures. The last 7 take half as long as the first 3. Okay?